Hi guys, Tin Man again. Well, I went to town and I got myself a watt meter, which is plugged into my extension cord, because if I plug it in the power point up there we can hardly see it. Of course nothing plugged into it, 0 watts. 246 volts, 50 hertz, which is our standard voltage over here for mains. That's our amp reading, and back to our watts. Now I've gone to a smaller transformer. There's the specs on it. Double tapped, double ended. It's got 0, 9 and 12. 0, 9 and 12. 60 VA. 60 VA. So that's what I'm using now to drop the voltage down. Here, clean this up a bit so you can see it's just one of Poppy's voltage doubler setups. Now I did try this with these two caps here, which are 470 UF 450 volt, and they were terrible. Drew way too much power and did only actually double the voltage, a little bit less than double the voltage. So my suggestion would be, if you're going to do something like this, get some big caps that put out a lot of amps, so every time your pulse motor pulses it hardly touches the current in the caps. So what I've done there is I've gone from these two through my amp meter and into a third cap, and then from that cap going to be driving the motor with that. This is to smooth out any pulses that the motor's pulling, so we get a good reading from our multimeter. Like I said before, this coil I wound 4 layers first of 0.33, I think it was, for the trigger coil, and I tapped every layer, so there's 1, 2, 3, 4 taps. And the reason I've done this is so I can drop the voltage or the current going through the resistor and the pot as the motor speeds up. The other thing I didn't mention was I've wired this up different. This was just a little experiment. I've gone straight from the start of the trigger coil into the base of the transistor. The end of the trigger coil is going through the resistor and then through the pot and then back into the emitter of the transformer. Now, this was just an experiment I wanted to do, and it works quite fine. And I'm not sure whether it has anything to do with these results we're getting here. Because I've dropped down in the voltage, I've gone back to one charge battery. This here, that's the voltage. Now this one's been resting overnight. I had it hooked up to this one before to do my test before I done the video. So 1268 is our rest voltage on that one. This of course is our amps. As you know, I hooked the amp meter up between the negative of the charge battery and the positive of our run battery. I've put a diode here before it goes through the amp meter and back into the cap to stop any back spikes or reverse voltages going back into the run capacitors. And that's basically it for the setup. So at the moment we've got, of course, 0 watts being drawn, transformer cord, a bit of home wiring. Yes, no, I didn't do it. Yes, I did. So I'll plug that in. I'll put the camera down for a minute to plug that in. Okay, we've got that plugged in. We've got 4.1 watts being drawn through the impedance of the transformer. As you can see, it's not hooked up. The caps only have 1.5 volts in them. I've also put this 10 watt globe, 12 volts, 10 watts, between 12 volts out and 12 volts in on the AC side. So that's also another indicator that we'll be drawing less than 10 watts. It will start to glow at about 5 watts at 12 volts. So that's just a backup telltale. So this 4.1 watts we have to take off of our reading on the end, because we don't want to know what the transformer is consuming when it's not loaded. We want to know what we're actually taking out of the transformer. So that has to come off of our calculations when we do them. Okay, our transformer voltage AC is 13.12 volts. Once rectified, it will be 12 volts or very close to it. And of course our caps are 1.52. Now you'll see my little light works when I hook up the wire to the transformer and charge the caps up. So like I said, they're a very high amp cap. They take a bit of juicing up to get going. So I'll hook that up. There you go, light starts. Once the caps fill up, the light goes out. Still our 13.13. Now once again, even with this transformer, 13.13, 3-hour voltage doubler should give us 26.26 or something like that, minus the losses in our diode, so it should be around 26 volts, but once again 35.2, 35.3 volts. So there's still a question in regards as to why. Like I said, with those smaller caps I only get about the 22 volts, 23 volts, but with these big caps I get 35, which is way over double. So anyway, to start this one up, I put it on the 3rd winding just because it'd be spinning slow. So we're going to start her up. Yeah, and we'll check our voltages on our run battery. 12.67, 0 going in at the moment, 0 being consumed by the motor because it's not running. 13.15 coming out of the transformer, 35.3, 35.4 volts in the 2 caps, and our 4.1 watts being chewed up by the impedance of the transformer. Okay, here we go. We'll start her up. As you can see, the light's coming on because we're over the 10. Once we back it off, as you can see, the light goes down. I can wind it up. Once I got it up and running, I can switch it over to the 2nd winding. Okay. Give it a bit of a tune over there. Now we're talking about sweet spots on motors and that. And as also wind the resistance up. Of course the voltage goes down, or the amp draw goes down. So we'll get it around 200 milliamps, an easy number to work with. Okay. Close enough. So now we've got 31.8 volts. Right. 208 milliamps. So 31.8 times 0.2 211 at the moment. So that's 6.7 watts of power the motor's consuming. At the moment we're using 7.8 watts. So if we go our 7.8 watts minus our 4.1 from the impedance, works out to be 3.7. So that's telling me that we're actually pulling more out of the caps than what we're putting out from the transformer. Not to mention, at the moment we have 115 milliamps at 12.77 volts. 0.115 times 12.77. There's another 1.4 watts going into that battery as well. Now, getting this watt meter was supposed to be solving my problems, and it doesn't seem to have solved anything. So we've got 8 there now. If we take our 4.1, that leaves us with 3.9 watts we're actually consuming from that transformer from the motor. We've got 31.4 at 0.224 amps. Which is 7 watts. So yeah, we're putting our 3.9 watts in, 7 watts out, just driving the motor. Plus we're also charging the battery at under an 18 milliamps. It's now at 12.79 volts, so it's going up quite quick. And that's pretty much where we're at the moment. So, meter's time's out. I'm still looking for answers, guys. It seems somehow we've made a power amplifier. Now the other way I can do this, disconnect that. Of course the motor will keep running, voltage will drop down on the caps quite quick because we were drawing a whole lot of current out of it. So yeah, the other way I can do this, take the lead from the transistor, a nice thick heavy one that I made, grab it here, remove our battery one. Now that's fallen off, I'll just have to put the camera back down again. Not being very nice. So what I've done there, you can overdrive come from our diode. I'm using a fast diode, it's a 5 amp one, ultra fast, 1000 volts, going through our thick lead back into our run battery, rather than hooking it up to the charge battery. So if I hook our thing back up, of course our lights will come back on for a bit till the caps are charged. The machine starts to fire back up. Give it a bit of juice, get it going. So just keep in mind what we're actually doing here is we're measuring the amount of power we can pull out of these caps compared to the amount of power from the transformer that we're putting into the caps. So this way gives us a bigger margin, of course, because we're not using any of the power to charge the battery. So at the moment, now because I've done that, the cap voltage will go up a bit because we're putting the high voltage spikes back into the cap as well. So their caps are at 33.4 and we're drawing 235, 236, it's still picking up a bit. Okay, so 33.5 at 230 milliamps. If we go to our lovely calculator, 33.5 volts times 0.200. So that gives us 6.7 watts is what we're pulling from those caps at the moment. Now from the transformer, we're pulling 5.4 watts. So we're already taking out more than we're putting in with the caps. But if we remember, 5.4 take away our 4.1 from the impedance of the transformer, leaves us with 1.3 watts is what's actually being consumed by the caps. As you can see, the globe's nowhere near. It's not even hot, it's cold. It's not glowing, so under 5 watts. So yeah, 5.4 take away our 4.1 from the impedance of the transformer, gives us 1.3 watts in for our 6.7 watts out of the cap. So that's just another way I've done it. So we could see the total amount coming out compared to the amount going in, without trying to add in the amount that's going into the battery as well. So that's where I am. Done what Polly said, went and got myself a watt meter, and it has answered none of my questions other than verified as to why I was getting amp readings on the meters, maybe 1 or 2 milliamps. So that's it guys, 5.4 watts minus our 4.1 gives us 1.3 watts going into our caps, and we're pulling 6.7 watts out of our caps. Now remember, with this meter here, I've got it in between these two caps to smooth out the pulses, so the meter's not playing funny buggers with us, it's a true reading. The voltage doubler is almost a doubler and a half. About 10 volts more than I should actually have in those caps. But it only seems to work with these caps, because with these smaller ones I draw a whole lot more watts power out, and that voltage there is only about 23 instead of 33, so definitely something in using the bigger, higher amp caps. Anyway, so still no closer to answering the questions I asked. However, we can clearly see now what kind of wattage we're putting into the caps and what kind of wattage we're pulling out of the caps. And I don't know, maybe we'll call it a power amplifier of some description. I'll post it on to our forum and let you guys have a look, see what answers you've got for me, because I'm having trouble finding them myself. Anyone that wants to come and be as confused as I am at the moment, iaec.forumco.com. Most browsers you'll have to use the HTTP instead of the www to get to our forum. Join up and come and make some wonderful confusing discoveries with us. Okay, cheers from the Tin Man.